So yesterday we did primarily SN1, SN2, SNI, NGP, SN1 dash, SN2 dash, right? All those things yesterday we did. Today we will go through the questions and we'll complete the standard pattern of this alkyl halide, aryl halide from preparation properties point of view. So let's start. Alkyl halides and aryl halides, replacement of hydrogen from aliphatic hydrocarbon by halogen will give you alkyl halide, and from aromatic hydrocarbon like benzene will give you aryl halide. When halogen is directly bonded to aromatic system, then you call it aryl halide. If it is connected to aliphatic system, okay, like methyl, phenyl, etc., then you call it alkyl halide. That is the way you will give name to aryl and alkyl halide. The difference, I would say, how would you name them? Right now, classification of alkyl aryl halide, of course, alkyl and aryl that we have done, but again based on number of halogen atoms. It could be monohalo compound, dihalo, polyhalo compounds, 3 or more. Now, 3 or more halogens we usually say, but refer NCERT, it has said one say more. Any halo compound which has more than one halogen is referred as polyhalo. Okay, I will show you the NCERT and we will see how it is mentioned. See, what I'm saying is this. This is the NCERT. I will discuss in the end of today's lecture. See, carbon compounds containing more than one halogen atom are usually referred to as polyhalogen. Okay, so anything that is having more than one will be taken as polyhalogen. So I will rather correct here more than one halogen atom is called polyhalogen. Need not to be 3 or more. ठीक, then type of halogen pe we have classification: alkyl fluoride, alkyl chloride, alkyl bromide, alkyl iodide. Like that way we can have a classification. Some important terms that we'll be using and name also may be required, like geminal dihalide. On the same carbon, if I have two halogens, then it is called geminal dihalide or gem dihalide. Vicinal dihalide, when the two halogens are placed on adjacent, then it is called vicinal dihalide. Common nomenclature of gem dihalide is alkylidene halide. Please remember this common nomenclature. Alkylidene halide. We don't have to call it dihalide. And when it is vicinal, then we call it alkylene. Check this difference. Alkylidene bole to on the same carbon. Alkylene matlab adjacent carbon. See, for example, if I have this ethylene, so you remove these two. Okay, what you will do is you will consider that these two are removed, and then what is the alkene? So you'll say ethylene. Give the common name to it, ethylene. And then you add just the halogen present. If you have more than one halogen types like chloride, bromide, then you refer them both, ethylene, chloride, bromide. And remember, it is a common word. Don't worry, what about the position and all these things. There are lacuna in this type of nomenclature. That is why we jump to IUPAC. So it is not that perfect, but can be used. And in mains 4-5 years back, they have asked this ethylene chloride reacted this way, right? So they may use this name in a question. Then you should not get confused. Ethylidene chloride. So what here they are using? So if you remember the name of alkyls, how we give this alkyl, if attached to somewhere, we call it alkylidene. So they have this ethylidene and chloride, means both valencies are now satisfied by chlorine. So these two common names you need to know, alkylidene and alkyne halide. Aryl halides, as we have already seen, simple direct name. Okay, this is not an aryl halide when Ring ko next carbon is sp3 and then halogen is attached. Then it is alkyl halide. Allyl halide, at halogen attached to allyl position, vinyl halogen directly attached to vinyl position. Nature of carbon halogen bond. Now see, this is something which can be asked any time because this NCERT table is part of our syllabus. See, bond length, fluorine, chlorine, bromine, iodine. If you see, bond length is continuously increasing. Okay, bond length is as expected, iodine, then bromine, then chlorine, then fluorine. Smaller atoms involved, then bond length will be lower. Now see the bond dissociation energies, bond enthalpies of these bond. Maximum is of carbon fluorine. This is the strongest. Then comes the carbon chlorine. Then comes the carbon bromine. And then comes the carbon iodine bond, which is the weakest. Right? Two things clear? Bond enthalpies and bond length. Bond length is continuously increasing. Bond enthalpies are decreasing. Coming to dipole moment. Now you check the dipole moment will be defined as bond polarity into distance, right? So if I go by simple distance logic, it should continuously increase, but no, it is not so. Please note how the dipole moments are shown in case of methyl halides, 1.86. So maximum is of carbon chlorine bond. Then is the carbon fluorine bond. Then is the carbon bromine, and then comes the carbon iodine bond. So please take a screenshot, and I'm not talking anywhere else. If you don't want to take screenshot, you can go for NCERT. There is a dipole moment table there, page, I don't remember, but table 10.2. So take a screenshot or read from there. But remember the order of dipole moment is Cl, F, Bri, Cl, F, Bri. That is the order of dipole moment of carbon halogen bond. Okay. Physical properties, again, table is from NCERT, this diagram, and how it can be used, that I'll share. So alkyl halides are colorless. Bromides and iodides after some time may develop color when exposed to light. Why? Because this carbon iodine and carbon bromine bond being relatively weaker, okay, can dissociate themselves and generate Br2 and I2 in the medium. Okay, so due to that presence, iodine and bromine, there is what should I say? There is a color generated in the medium. So that is why after some time you will observe this. But I'm not saying that this is going to be always. You can't say that this is going to be always. This is going to be only when they are exposed to light. If they are freshly prepared, so bache, then bromides and iodides are also colorless. Is that okay? Now see this. What is shown here? For same alkyl halide, for some alkyl halides, if you see CH₃X, here it is given chloride, bromide, and iodides. Okay, for the same halide, for the same alkyl, see CH₃X. If the alkyl is kept same, count of halogen is kept same. You are with me fully? See, iodides have the maximum boiling point, then the bromide, then the chloride. When you go from CH₃X to CH₃CH2X, this point remains same, iodide highest, then bromide, then chloride. Now see for the red column only, there is a continuous increase as we are increasing the size of alkyl. Blue column, same thing. Yellow, same thing. Right? So if halogen is kept same and molecular weight of alkyl is increased, then boiling point is increasing. This we can deduce from here. Okay. And If the alkyl is kept same and halogen is changed, then heavier the halogen, more the boiling point. This also we can infer from here. Is that fine? Then we can be asked for the same alkyl order of BP this way. For isomeric alkyl halide, if formula is absolutely same, then boiling point decreases with branching. More the branching, less will be the boiling point. See? Right? Now see here, this is a 2 degree, 3 degree. So 3 degree is taken as more branching. Okay? But you cannot simply say 1 degree and 2 degree also have the similar trend. It is 3 degree, then this one 1 degree, then least is 3 degree, then it is thoda sa higher is 2 degree. Okay, and then comes the primary. This is how I propose a question can be formulated. See, I can make these products by addition of HBr, HBr peroxide, or simple addition of HBr and get ABC. And then ask what is the order of boiling point for these ABC. So this knowledge can be directly or indirectly used for making good questions. Is that fine? Coming to isomeric dihalobenzene. Now here also there is a problem. If you want to predict directly their boiling point, it is not so. See, boiling point order is ortho is maximum 453. Then comes the para 448. Yes, meta and para have negligible difference. But if order asked, then order asked. Can't help. Ortho, then para, then meta. Opium. Whereas for melting point, para always major because of the symmetry, and symmetry gives it a better packing. They are closely packed. So para, then comes the ortho, then comes the meta. See 323, then 256, then 249. Okay, again a very important point. We are leading to density. Bromo, iodo, polychloro compounds. Repeat, bromo, iodo and polychloro. ठीक? See bromo 1.335, iodo 1.747, and all polychloro CH₂Cl₂, CHCl₃, CCl₄, all. Okay, these are heavier than water. Rest are less dense than water. Rest बोले तो क्या? Fluoro compounds and monochloro compounds are less dense than water. Okay, so with increase in molecular weight, density increases. With increase in atomic mass of halogens, also density is increasing. Okay, see C3, chlorine to bromine, density is increasing. From bromine to iodine, density is increasing. Okay, so with increase in atomic mass of halogen, there is an increase in density of the compound. Absolutely clear. Now, what type of question we can expect? As we have just decided that chloroform, bromoform, carbon tetrachloride, CH2Cl2, these are all more dense than water. There is one particular method of purification that is called solvent extraction. So this is what is, I'm framing a question, that if bromine is dissolved in CCl4 and there is this one aqueous layer, and this aqueous layer may be having, let us say, they say NaBr is dissolved in water and bromine is dissolved in CCl4. The two layers are shaken and mixed and then placed in that solvent separation method where you come across this type of thing. ऊपर से we can fill whatever way they give. And then from here we collect what is coming first. So if we are asked that they are taken and then kept in solvent separated funnel, which will be separated or which will come first. So see this blue layer I am making, I hope this is absolutely clear to you, will be the aqueous layer. And this green layer I made is of organic layer. Right? This we are talking, na, this thing. So when I will open this, ठीक, open the nozzle. If I'll open this nozzle, definitely what will happen? The organic layer will start coming out fast. Right? I will open, so my beaker will start having green liquid coming out of it. Okay, green liquid is coming out of it, and the blue liquid will now be here. Is that absolutely clear? So that type of question you can expect on this simple density thing. So here you think organic layer comes out because it was below. Aqueous layer is still here. So here NaBr is inside this aqueous layer and bromine came into this organic layer. So this type of question could be framed with simple density logic. Okay, so these are all. बोलने को है कि सिर्फ physical properties ही है, but ये physical properties पे बहुत अच्छे सवाल बन सकते हैं. Please don't neglect them. और फिर वो एकदम से when they appear in exams, it give you chills ki what, from where they are asking. So these tables in the NCERT, okay, these datas type table in the NCERT, pay attention to them, spare 4-5 minutes on them and you will get the question. Okay, so coming back to where we were, so we have discussed the density. Water solubility, with increase in mass, water solubility will decrease. Okay, because we are mentioning that with increase in mass, it means the alkyl part is being increased, which is hydrophobic. So for isomeric molecules, with increase in branching, water solubility will increase. Coming to molecular dipole moment of methyl halides. Yes, I do remember that this is a question for halogen only in NCERT and is given twice in your entire NCERT, once in a chemical bonding and then again in alkyl halide. 2 times this question has been framed in NCERT. Okay, so if you check the dipole moment for chlorine, which is given in NCERT, the order is CH₃Cl, then CH₂Cl₂, then CHCl₃, then CCl₄. That is the order. Okay, then comes the bromine, same order. For the iodine, same order. So monohalo, dihalo, trihalo, tetrahalo. 1, 2, 3, 4 is the order for alkyl chloride, bromide and iodide. But for fluoride, which this question was asked in NSCC. Okay, and this is asked in JEE. So they both are important for us, whichever can appear. So for fluorine, it is found to be CH2F2, then CH3F, then CHF3, and then CF4. Okay, so what is the difference? For chlorine, bromine, it is 1, 2, 3, 4. And for fluorines, it is 2, 1, 3, 4. Right? So this is important based on the dipole moment. Moving further. Methods of preparation in alkenes we have done. Addition of HX, addition of interhalogen compounds, use of NBS, those are repeated. HX, so yes, you can add HBr in H2O2, this is an anti-Marconic of addition of bromine. Using NBS, which is allylic bromination, you can do like this. Right? Now, mechanism, what is the purpose of NBS? Last week we have done it. Functions as a continuous and a gradual source of bromine. Bromine aata rahega and it breaks like this. 2Br dot chain initiation takes place. Okay? So this bromine allyl more stable, so preferred. Now see, 2 degree is unstable, so it is not formed. Now this allyl radical when attacked Pr2, we get this type of product. Okay. On NBS, this reaction, the question was asked in 2021. Though they have given different multiple keys, 9, 13 and 14. But the most appropriate was using NBS. How many products are formed? How many products are formed? So let us see. They have given with bromine and HNU. Okay. But I have changed it to NBS. The concept was asked in advanced 2021. I have told you this thing in alkene also, but let me reaffirm what I want from you. For such questions, I want you to always, let me add a page rather, so systematic chalte hum. Whenever they give you any compound for NBS, I want you first and foremost write what are the different types of radicals which could be obtained like this. I can have this radical and I can have this radical. First, you form all the possible radicals. Then you draw their resonating structures. So you will get some different structural products then. So I'm writing just the resonating structures of the possible radicals I have got. 3 radicals I could get, 3 RS I have drawn. Now corresponding to them, you add bromine. You attack bromine. So I will have this. On this, if it is attacked, I will have this. So just simply first draw structures. Don't be worried about stereo. Go step by step. If you'll try to do everything at a time, you will end up doing error. So just first all the radicals we have drawn. Second, we have taken all the bromine attacks. Gradually you move. Okay, so I have got bromine and I will draw this one also. And I have got bromine again. Okay, so step 2, I have drawn all the structures. Now I will check individually what is the status of their this optical and geometrical isomerism. So here I do not see any GI or OI. So I'll say only one product will be counted for this. Okay, coming to here, this center is chiral. See, bromine could be on wedge, could be on dash. So you can write 2 cases are possible like that. Now coming here, this again is wedge and dash. This center is chiral, right? Both are possibilities. So I'll write 2 products. And in doing this, please note that it should not be that you get a repeat of a particular structure. Okay, it should be only once counting should be done, not like the same structure written twice, thrice, and we have done a repeat counting. That we need to take care. Now here I can see again 2. Okay, this is chiral. Right? Now checking these, IUPAC wise they are appearing same. Right? Whether I go for this or go for this, they are appearing same. But still I will say this is chiral. Either it will be wedge or it will be dash. Right? So I will say, yes, they are same. But still due to chiral, I have to count it as 2. Once you do all this exercise, now you add. So I can see 8, 4 2s and 1 1. So I will report the answer for this is 9. So be very gradual for number of isomer question, and then you can still have some errors. This is a area which has no end to it. Ki what will be the final status? There is always a fear of error in number of isomer questions, but if you'll go slow and a little controlled, you will find less chances of error. Okay, so please take care, go slow, draw all the structures in your rough notebook, and that would be helpful. Moving to NBS in water. So this was when NBS is given with HBr, then you do this allylic radical thing. But if NBS in water is given, then what to do? So see, first let me tell you what is this NBS in water. N bromine is there, water is there. But here if you see, this is del minus, this is del positive. So when we talk of mechanism, this alkene reacts with NBS. So NBS is also source of Br positive, not only radical. So Br positive, we have a non-classical carbocation formed. And now water attack on this. So if water will attack on this and ring opens, this bromine and this OH, of course, H plus will be released. So if NBS with water is given, then you report your answer on alkenes as halohydrate. But if NPS with HBr is given, then you report as allyl radical. I hope this is absolutely clear and you will not do errors with this. So coming back to where we were, that what is the method of reactions for alkyl halide. So from alcohols and ethers using PCl5 or PCl3. Okay, so this is preparation only we are doing. So alcohols, yesterday we did that if you use HCl, you can have a racemic mixture as the mechanism could be SN1. I am not saying always SN1 because methyl halide and primary halides can go by SN2, right? So PCl5 always SN2, inversion. SOCl2 was SNI, retention of configuration will be observed. This is what we have done. Okay, so moving forward, from alkenes by addition of halogens, from alkanes by radical halogenation, then there was Finkelstein and Schwarz reaction, which we did yesterday in SN2. Okay, now let us go to aryl halide preparations. Preparation of aryl halides. First and foremost, chapter benzene. If you take iron, AlCl3 and halogen, then you can prepare aryl halides. Of course, not PHF. PHF can be prepared only by one method. Then there is Sandmeyer, diazoniums treated with CO2Cl2 HCl, PHCl. CO2Br to HBr, pH, Br is observed. Fluorobenzenes can be prepared only by one method. Okay, this is only method to prepare PHF. Fluorobenzene ke liye we do not have any other alternative method. How do? We prepare from diazonium. We heat it with HbF4. Okay, tetrafluoroboric acid, and we get a precipitate of diazonium tetrafluoroborate. Okay, we remove it, we dry it, and we heat that dry precipitate, and we get fluorobenzene. This is called Ball-Schiemann reaction. You can have a direct attack of I- by the use of Ki, iodobenzene is formed. Okay, these are our methods of preparation. Reactions of alkyl and aryl halide done in part 1. That is yesterday alkyl halide part 1 when we did. Reaction with metals, yes, you can make Grignard like this, Rx plus magnesium forming RMGX, and how it is gone. I'm not dealing with the entire reaction of Grignard because it is in next week. So just rough I'm talking. So Mg2 plus 2 electron R minus X minus, you'll get a Grignard reagent. Okay, so the most important reaction which can appear this week also is its acid-base reaction. So that we should be ready anytime it could appear, that Grignard will react acid-base reactions with water, alcohol, RNH2, terminal alkyne, phenol, acid, active methylene group, or cyclopentadiene. All these could be a source of reaction for Grignard. Now, these are there, I'll share in the notes, but I'll not recommend that this week you pay much attention to these reactions, but they are there. Okay, let us go to the POC, that is practical organic chemistry of alkyl halides. So first is the Beilstein test. Now, Beilstein test, all alkyl halides when burnt on copper wire burns with green color flame. Now, this is with all alkyl halide, irrespective of whether it is chlorine or bromine or iodine, and even aryl halides also. Okay, this is for both alkyl and aryl halides. ये दोनों ही ये reaction देते हैं. Alkyl and aryl halides all give this test positive. Okay, then comes those alkyl halides which can form stable carbocation with precipitate, give precipitate with AgNO3. So if I have silver nitrate, okay, and see, I have two halogens in this ring. Carefully watch. Bromine is attached to ring, and yesterday only we saw that attached halogen attached directly to the ring cannot be removed. They have high bond dissociation energy. They will not form a carbocation. So this is not my suitable choice. I will remove this iodine and will have this alcohol formed. But observation will be I am getting yellow precipitate of AgI. If I interchange this iodine bromine, you can see this bromine AgNO3. So AgBr precipitate is now formed. If I had like this, AgCl. So what you're seeing that those which are directly attached to the ring are not participating in carbocation. And only those which can form a stable carbocation will participate. Now this stable carbocation thing could be very well, like for this, very easy aromatic compound will be formed. And the only thing we want is a stable carbocation, like this, right? And remember this one thing, that even if it is medium में water or anything given, never form a bond. Okay, this is never formed. It will remain as ionic always. It will never form a bond because converting from this ion to neutral species, forming a bond will convert it to from aromatic to non-aromatic. Okay, this was one's main question, that what will be the product form. So it will not form this product. It will not form this type of bond. Clear? Moving further, sodium fusion test. So lysine extract or AgNO3, if we react, then it forms silver halide. Now, do you remember lysine extract? We react with sodium. Organic compound is treated with sodium. Let me elaborate on three. We have organic compound. We treat it with sodium. If it is having halogen, NaX is formed. And this is in lysinase extract, also called sodium extract or sodium fusion extract. Any word you can find. And now it is in ionic form. So if I add AgNO3, I will get AgX precipitate. If it is chlorine, the white, right? White for AgCl. And of course, one extra information, soluble in ammonia. Take. If it is light yellow, then it is AgBr. If it is dark yellow, then it is AgI. AgI. So this is how we report which halogen is there. Absolutely clear. Then comes the Carious method of estimation. Now see, Lysines extract method is a qualitative, is a qualitative analysis that you just confirm that halogen is there. But Carious method of estimation is quantitative method of estimation. Is that absolutely clear? That Carious method is the quantitative method, and this method, what other was Lysines is qualitative method. Okay. Now, once we have this method defined, how is Carious method working? Let us see. In case of Carious method, I want to show that there is a fusion tube they take. Okay. And in that fusion tube, we have to heat our organic compound. And again, we have to do the same thing. We have to fuse it completely, because in organic compound, halogen, if present, is still in what form? It is still in the form of this covalent compound. Okay. So I'm just bringing that. I want you to just go through this. This is what I want, so that you just see this is a very strong fusion tube. Okay. In this, we keep our organic compound. See, strong multi-carious tube. A known mass of an organic compound is heated with fuming nitric acid. We take fuming nitric acid so that it dissolves the organic compound completely, and it just convert it. It just decompose it in the presence of silver nitrate contained in a hard glass tube known as carious tube, like this. Okay. Inside this, we have kept like this in the small fusion tube के अंदर organic compound, and fuming HNO3 we are adding. Our organic compound totally decompose, and whatever halogen is present in it comes out as X, and AgNO3 we add, then AgX is precipitated. And by the knowledge of what amount of AgX is precipitated, we come to know that what was the amount of halogen present in it. So this Carious method is quantitative. It tells you the quantity of halogen which is present. And Lysines test is qualitative. Okay. I want also for you to see a Bilstein test color. Okay. So give me a second and I'll share the screen. I want you कि आप Bilstein test का एक वीडियो मेरे साथ देख ही लें, so that you will always remember how the Bilstein test works. And the color I want to actually see. So I'll stop sharing and I will share. Right. I don't know voice will come or not.
Has to be done outside or in a fume room. I don't take any responsibility for damage done to persons or property caused by the recreation of this experiment. Clamp or tongs to open a copper wire and test the following condition of this
Just
experiment.
watch it carefully, mainly the colors.
The following burner, copper wire, clamp or tongs to hold the wire, and optionally a porcelain dish to hold the sample. In addition to that, the test is done in low light conditions.
Low light
First,
conditions.
the Bunsen burner is ignited and the copper wire is heated in the roaring flame until no green flame coloration can be observed anymore. It has to be taken care that no higher amounts of halogenated compound compounds are in the air, like for example hydrochloric acid or solvents. Due to the heat, the copper reacts to form copper-2 oxide. According to the protocol, the sample is then placed on the glowing wire, where especially liquid compounds are likely not to stick to the hot surface, so it was left to cool in the liquid. Practically, the wire could also be left to cool before dipping it into the sample, but there's a slight risk of it being contaminated by dust particles in the air. At first, benzaldehyde was tested, which should give a negative result. I was curious whether it was possible to prove that it is industrially made by the hydrolysis of benzyl chloride. Nevertheless, even though it was technical grade, it was obviously still pure enough. Next, Parlem was tested, which is chlorinated rubber with a chlorine content of 68 weight%. This did obviously give a positive result and is also used in pyrotechnics to intensify the flame coloration.
See the green color. After some time, green color goes.
Different substances are formed, of which some, like hydrogen chloride, can react with copper oxide to form copper-2 halides. These are able to evaporate, leading to the flame coloration of copper. To test for different halogens, bromobenzene was used here, which did also
the aromatic also reacting.
There was no organic iodine compound available, so as a substitute, elemental iodine was tested because it could also react with copper to form copper-1 iodide. At the end, I was curious if a highly volatile compound could even be tested, so dichloromethane with a boiling point of 39.7 degrees C was used. As it could be seen with the Wallstein test, lots of compounds can easily be tested for halogens. This was the Wallstein test.
Okay, so this is how this Wallstein thing is to be used. Okay, coming back to our notes. But remember how it appears a green color flame very clearly visible is the test for Wallstein test. KRS I have defined, sodium fusion extract I have done, and the precipitation thing could be there, which is done, right? Coming to polyhalogen compound, don't ignore those last 2-3 pages of NCERT. So definition, as I have already told, containing more than one halogen will be polyhalogen. Haloform, CH₃ fluoroform, chloroform, bromoform, iodoform. Now, iodoform is yellow solid with foul smell. Iodine ki smell hai usme, that is why is used as antiseptic. Okay, chloroform is colorless, sweet smelling liquid and has anesthetic properties. CCl₄ carbon tetrachloride, commercially it is known as pyrene. It is used as a fire extinguisher. DDT, which is used as insecticide. Chloroform and other haloforms. See, remember all these data. So I was telling that you have to remember these values like chloroform, see dipolement is greater than 1. We have already discussed all polychloro carbon compounds will have dipolement greater than 1. Molecular weight, density greater than 1. Dipolement, we discussed that is high, but how much? It is 1.15 dpi. Molecular weight you can calculate. It is slightly soluble, negligibly I would say soluble in water. See, something which is 119 grams and only 8 gram per liter is soluble. So it is negligibly soluble. Boiling point is 61 degrees centigrade, good solvent for organic compound. pKa of chloroform is 15.7, which is, I would say, quite high. Like water, it is close to water, right? So why? Because of the d orbital resonance of this anion into 3 chlorines. That is why it is high. Absolutely clear. So that is how it is behaving as a high, what should I say, acidic nature. and you can remove this H by the use of NaOH and all those things and form carbenes wherever required. Coming to preparation of halo compounds, we have methane, say chlorine attach gate directly in HNU, right? So we can have this prepared, but it's certainly not a very good method for chloroform preparation because there will always be a drawback of forming other type of halogen. CCl4 bhi ban sakta, CH3Cl bhi, CH2Cl2 bhi. So how to control that only chloroform is formed? That is difficult. Then comes the haloform reaction, which is in fact the best and the industrial method for preparation of chloroform. Okay, so we will discuss it later in whichever week we'll get haloform in our syllabus, but at least this much you can see that ethanol and other 2-degree methyl alcohols. So there this CH3 part will go to haloform and the rest over part will go to acid. If I'm using bleaching powder, I'll report as a calcium salt. If I'm using NaOCl, I will report as a sodium salt. You can have NaOH plus Cl2 also. Ethanol and bleaching powder reaction, this combination is what is industrial method of preparation of chloroform. This one. Okay. So please take this method as industrial method of chloroform preparation. This is the industrial method. The reactions where chloroforms are used, first you can have directly silver dust or silver powder and acetylene is formed like this. So it is not just that acetylene could be formed. As I'm discussing only chloroform, so I'm forming acetylene. This could be of any gem trihaloalkane property. It could be R, this could be R dash, and you can have any higher alkyne formed by this type of method. It can act as a source of nucleophile. This is important. See, chloroform with base is a magical reagent. It can give you nucleophile, it can give you electrophile also. Based on our requirement, what we want to make, like if I use with KOH, I will have nucleophile formed, C minus. This C minus, if there is a place of attack, can attack directly and you will have the product form. If it removes Cl and form carbene, then it is electrophile. Now let me exemplify what I'm saying. This point, nucleophile, electrophile, sub point 2 I am exemplifying. See, for acetone, this is del plus. So once the reaction is initiated and I have this anion formed, why would not the reaction take place here only that it attacks as a nucleophile? There is no point to form a carbene. Okay, once this is formed, it will attack and you will have a very famous compound called chloritone. What we get is a chloritone. It is a water purifier. It is used as a source of chlorine. Chloritone is formed. Okay, by simple nucleophilic addition. But if I take on phenol, now in phenol, if I form CCl3 minus, this is a strong electron dense and that phenol phenoxide rings are also electron dense. So there is no possibility of reaction between these two electron dense systems. And thus I get a time opportunity or a chance to shift to dichlorocarbene. Okay. And now when we get a chance to form a dichlorocarbene, this dichlorocarbene will attack on phenoxide. Okay. And when this attack on phenoxide, you have a very famous reaction called Riemann-Tiemann. Is that clear? Riemann-Tiemann is an example where you are using this dichlorocarbene for nucleophilic as an electrophile attacking on nucleophilic reagents. Okay. Whereas this is when you are having dichlorocarbene forming a nucleophile attacking on electrophilic reagents. One more example to add. See the difference. Same reagent giving you 3 different reactions. Here it was acting as a CCl3 minus. Here carbene attacking on the aromatic ring, and here also carbene but attacking on nitrogen. See RNH2, it is attacking on RNH2, chloroform plus KOH, forming CCl3 minus, then to dichlorocarbene, and then this lone pair directly attacking to dichlorocarbene. This is POC for primary amines, carbylamine reaction, you get there. Same reagent behaving three different, I should say, influencing three different important reactions. Our last two are very important. Primary amine with dichlorocarbene, you have alkyl isocyanide, carbylamine test, POC of amines, foul smelling compound. Okay, so that same thing is behaving in a different way. Coming to third point of this chloroform, if it is treated with HF, it forms CHCl₂F2, chlorofluorocarbon. And this chlorofluorocarbon, if heated at 750 to 800 degrees centigrade, it forms through carbene, of course. First it forms carbene, and by carbene, through carbene, it forms this compound, tetrafluoroethene, which polymerizes to a famous polymer called Teflon. Okay, see, this can be obtained directly from CHF3 also. That is also a carbene method, and you get Teflon. Chloroform reacts directly with HNO3, and this HNO3 is concentrated. We take concentrated HNO3. How it is reacting? Like this: Cl, 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 HONO2, and we get chloropicrene, which is a tear gas, right? The same tear gas which we hear in news, the police department use tear gas, the same tear gas is mentioned. Okay, then comes the chloroform if fused with NaOH. See, it is a trihalo compound, CHCl₃Cl, though what I'm saying is not the direct mechanism, but attack Cl gone, Cl gone, Cl gone. This is just a method to remember, but not the mechanism. See, H2O gone, you will have formic acid. And as the medium is of NaOH, so definitely formic acid salt is formed. Right? Again, if they ask mechanism, this also goes through carbene. Okay, this also goes through carbene. Reduction of chloroform. And see, with zinc and HCl, I'm not getting methane directly. You will get CH2Cl2, but with zinc and steam, we get methane. Right? This is the reduction. Historically, it was used as an anesthetic, but it is now banned. Why? Due to the formation of poisonous phosgene. To avoid phosgene, this is important line, it is stored in dark colored, airtight or wax coated bottles. Ethanol is also added to this bottle. Okay. Pyrene CCl4 is a fire extinguisher, organic compound which is non-inflammable. So I was telling that pyrene is a fire extinguisher. It is an organic compound which is non-inflammable. It itself do not catch fire. But at 350 degrees centigrade and higher, it reacts with CO2 and form phosgene. And with carbon monoxide also it is forming phosgene. So that is a problem. When this phosgene is formed with such a heavy molecular mass, so if you are using carbon tetrachloride as a fire extinguisher, then you cannot open the space directly for human use, because this phosgene with high molecular mass is, deposited at height of a room. Okay, so the environment is very poisonous unless this entire phosgene diffuses out. We will not have human activities at places where phosgene, where CCl4 is used as fire extinguisher. Okay, the other important reactions are like this: P2O5, it also forms phosgene. ZNO ke saath it is forming phosgene. So these are other reactions. With HF, it is ultimately forming chlorofluorocarbons, and then finally CF4. Okay. DDT, extremely important polyhalo compound. This is the structure, and it is formed by reaction of chloral and chlorobenzene. Chlorobenzene. Like this, para position is attacked, and we get DDT. 1,1,1 trichloro, 2,2 bis, 4-chlorophenylethane is called DDT. Okay, mechanism is there. You can have, like in presence of H2SO4, protonation of chloral takes place, and then para position is attacked by chlorobenzene. Okay, and then we have this medium is acidic as H2SO4 is used. So you remove water after protonation of this OH, carbocation, as it is a very bulky electrophile, so it always attacks at para positions. Okay, due to its bulky nature, it always attacks at para positions. Is that absolutely clear? And then finally we have DDT, which was used as a mosquito repellent for a very long time. But again, due to pollution and environmental studies, it has been now completely banned. Okay. See, in 1874, first synthesis by Zidler. Its insecticide properties were researched by Mueller in 1939. World War II was used. It was used extensively to kill malarial mosquito and typhus. Currently, it is banned. उस समय इस तरह से एरोप्लेन से देखो पूरा का पूरा स्प्रे होता था. This is how it was sprayed. Okay, and this is how it was sold. This type of packaging was there. Use on potatoes, peas, corn, fruits, and ornamentals. Everywhere it was allowed and killed the mosquitoes. And even many other common mistakes, but is now totally banned. Today we don't use this particular thing. Okay, as it causes accumulation of chlorine in the environment, and we don't want that type of thing. Is that absolutely clear? Okay. Then comes the freon. If we go to freon, see, freon is chlorofluoro, CCl₃F, then it is called freon 11 or F11 or R11. Cl₂F2, then 1,2, it is called freon 1,2 or 1,2, F12 or R12. Important note, vicinal diiodides are always unstable. If there is vicinal, gem diiodides are stable. Iodoform, if you have, no problem, it is stable. But if you have vicinal diiodide, they always decompose, they always break and form alkene. Okay, alkyl halide plus aqueous Ag2O if given, then form alcohol, dry Ag2O, then ether. This is one extra information. Let us come to the questions, PYQ, and then I will entertain your doubts. Okay, meanwhile, if you have anything important and have to say something very important, you can raise your hand. Now we are starting the discussion. We are left with 15 minutes and I want to have at least 4 or 5 questions to be done. So this was one of the questions which was yesterday's class relevant question, but what to see, how to solve it. I think now you can solve it quite clearly. CH3CHBr CD3 on treatment with alcoholic KOH gives CH2 double bond CHCd3. So it is not attacking on this side deuterium. It is attacking on CH2 side. This is what we are concluding. So it is showing, this observation is showing that A is having Ki effect. And Ki effect was primarily shown by E2. So it appears that A should go to Q. Right? PHCHBr CH3 reacts faster than PHCHBr CD3. Okay, so this is again showing that it is reacting faster. मतलब hydrogen से deuterium change हुआ, so there was an impact. Is that absolutely clear? So there is again, this point is again showing that B is showing Ki effect, and Ki effect means Q. E2 shows kinetic isotope effect, right? This was year 2006. At that time, we had to match the column. We have to fill the blocks Q, R, S like that. So it was not an option based. It can be now made option based. pH CD2 CH2Br on treatment with ethoxide gives